Hi guys, so in this video we'll be going over the homework 5 problems, and for this week it's the chapter 1 section 7, which is the general equation of the first order, which is a continuation of last week's lesson on the specific form of y prime plus a y equals to b of x. So it's more generalized case, and this is the last section of this chapter before we go on to the linear equation with constant coefficients. All right, so let's take a look at some of the problems that'll probably help you with the this week's homework. So I assigned number 1 and I assigned A through D. So I would like to go over part E with you. Alright, so let's do E together. So if you guys remember, our textbook uses the format of y prime plus y times a of x equals to b of x. Okay, so just to find out what the just to identify what a of b and b of x are, for our case E, our a of x would be 2x, and b of x will be this whole thing. Okay, we have to identify what a of x is because it's important for us. That'll play a major role in getting us the integrating factor. So we need the integrating factor to differentiate this equation. So if you guys remember, our integrating factor was e to the power of ax. Oops. And that would be the differentiated form of that. All right, so let's write down. So that's going to give us e to the power of 2x differentiated, integral of 2x of dx. So this will give us e to the power of x squared. Okay, so our second step after finding out what our integrating factor was, we have to multiply this factor to our equation. So that's going to be e to the power of x to the second, y prime plus 2xy. It's going to equal to e to the power of x squared times x times e to the power of negative x squared. All right, and our third step was to apply integral of both sides. And I can distribute my left-hand side, so that's going to give us e to the power of x squared y prime plus e squared 2xy dx. And my right-hand side is going to be, we would have to, if you notice, there's two parts. So the rule of exponents goes, if you have the same exponent, a to the power of b times a to the power of c, then what happens is that that base gets kept and it ends up being b plus c. Since we have the same base as e, our exponents will get added. So let's apply that. So e to the power of x squared plus negative x squared times x of dx. So we know that this is going to be e to the power of 0, which is just 1. Okay. And all right, so the left-hand side, you can kind of guess, take a look and notice that this entire side is just going to be e to the power of x squared y. Okay. And you can check by using the chain rule. If you differentiate this, then you'll get to this part. Okay, so we have that, and I'll write this out once more so that this part is just 1, so we have x dx. So I think this part is pretty simple to integrate, so we have 1/2 x squared plus c. Don't forget about our constant. All right, so this is what we get to. And remember how we have to get the y by itself, so I'm going to divide both sides by this. So we'll come to y equals to 1/2 x squared times e to the power of negative x squared plus c times e to the power of negative x squared. Okay, so this is our answer, and don't forget to put that c is any constant. So we have solved our differential equation for part E. All right, let's move on. Let's take a look at number 2. Both parts A and B are assigned, so I'm going to go ahead and do part A together, and I'll leave the part B to you guys. Okay, so find the solution of theta or phi which satisfies this equation. So it seems like we have to find the differential, we have to solve this equation first. Okay, and I noticed that this cosine of x is our a of x, and this entire right-hand side is our b of x. Okay, all right, so again, I can go ahead and find our integrating factor, which is e, the integral of a of x dx. So this is going to be e to the power of the integral of cosine x dx. All right, so the integral of cosine x is sine x, so we know that this is going to be our integrating factor. All right, so second step was that we would multiply our integrating factor to both sides of our equation. So we have e sine of x y prime plus e sine of x cosine of x times y equals to e to the sine of x times e to the power of negative sine x. Okay, our third step is to differentiate both sides. And I also noticed that this, according to our previous exponential rule, the base is the same, which means our exponents will get added. So I immediately noticed that this is simply e to the power of 0, because positive sign plus negative sign is going to result in 0, dx. And don't forget about the dx to apply both sides. Okay, and this side we have e to the power of sine x times y. Okay, so let's quickly go ahead and solve this. It's going to equal to, this is 1, so we have 1 dx, so we get to that, x plus c. Okay, and let's divide both sides by e to the power of sine x to get the y by itself. So we have y equals to x times e to the power of negative sine x plus c times e to the power of negative sine x. All right, where c is any constant. So we would stop here if we were talking about just the just finding our solution. But here we're given the boundary, which means we can go ahead and actually solve for c. Okay, so I'm gonna do this, apply this part. So we have theta pi equals 2. Now we're just plugging in pi for our x. So we have pi times e to the power of negative sine pi plus c e to the power of sine of pi. We know that sine pi, it's 0. So this gives us pi e to the power of 0 plus c e to the power of 0. And we know that this e to the power of 0 is 1. Oh, and also notice how this, after we plug in pi, our result should equal to pi. Okay. All right, so rewriting this, we have pi plus c equals to pi, which gets us that the value of c, our constant value, is 0. Okay, so there we go. So we were able to solve for the solution, which is y equals to x e to the power of negative sign x. We get to this because c is, this value is 0, so 0 times whatever we have, that's going to result in 0. Okay, so that was part A. I will leave part B to you guys, and now you can utilize this. Right, so this, again, you guys can just write this as pi of x, theta of x, okay? So you can use this equation and plug in the appropriate values for x and set that equal to pi times k, and your task is to find the value of k. All right, and I think the rest of the problems that I assigned pretty much echoes this basic concept that I just went over. So I would like to leave it up to you guys to give it a try. I think there are good challenging problems that makes you guys will have to think about a little bit. And please do email me if you're stuck on any of the problems. I would, if we can't arrange a time to go over the problems online during the online office hours, then I can certainly make videos of your question or write up the solution and post it for your use.